Hello everyone, welcome to the lesson on lists. This lesson is part of the course Python for Beginners. In this lesson, we will discuss how to use lists to store and manipulate a collection of values. This is the color coding we will be using throughout this lesson. Please take a moment and have a look. This lesson is structured as follows. First, we will introduce the idea of a collection of values and how lists can be used to handle them. Next, we will discuss in detail how to access and update a list. Under updating a list, we will talk about append, modify, and delete operations. After that, we will look at multidimensional lists and some common list operations. Finally, we will conclude this lesson with indexing and slicing. Further, throughout this lesson, we will go through several examples and practice exercises that will help you understand the concepts well. In the previous lessons, you have learned about the text and numeric data types. We use the string data type to store text, and numeric values can be stored using the integer, float, and complex data types. Here are two examples. The string Rohan is stored in the variable name, and the number 20 is stored in the variable age. If we take a closer look at it, we only know how to store a single value per variable. An important question you have to ask at this point is, what if we need to store more than one value per variable? Please pause the video and take a moment to think about it. Before answering that question, is there an actual need to store many values in a variable? Let's take an example. Suppose you need to roll a dice n times and store the obtained values. Again, pause the video and take a moment to think how you can do that. A simple and straightforward approach is to use one variable per value of a roll. As shown here, you roll the dice once and store its value in the variable roll1. You roll the dice again, and you store its value in the variable roll2. You follow this pattern until the last roll. Now, do you see any problem with this approach? As many of you have guessed correctly, there are indeed several problems. First, what if you do not know the value of n beforehand? Let's say you develop a program where users can store the things they buy in a supermarket. One day they might buy 10 things, and another day they might buy 100 things. Hence, we cannot decide how many variables we need in advance. Second, what if the value of n is very large, say n is equal to 10,000? Creating and managing 10,000 variables is a difficult task. So, what is the solution to these problems? The solution is to use container data types. Container data types allow us to store more than one value in a variable. If we go back to our rolling dice example, using container data types, we can store all the n values in a single variable as shown in the diagram. We will learn how to do that in a moment. Python supports many container data types. Some of them are list, tuple, range, and set. Please note that there are many more. In this lesson, we will direct our focus towards lists. Let me start the discussion on list by introducing the basic structure of a list. A list holds comma-separated values between square brackets. Here is an example of a list in Python, which contains 4 numbers, 1, 2, 3, and 4. As you can see clearly, the values are comma-separated and are within square brackets. One important property of lists in Python is that the values within a list need not be of the same data type. To get a better understanding, let us look at a few examples. List 1 contains a collection of numbers. List 2 contains a collection of strings. List 3, on the other hand, contains strings, an integer, and a floating point number, which are all different data types. In the last few slides, we looked at the basic structure of a list and how to create lists. Now, the next step is to learn how to access the values in a list that you have created. To understand things easily, let us take a real-world example. Assume that you go to a library and you want to borrow a specific book on Python programming. The library has books organized on shelves. You find the book you need, which is the second one as shown in the diagram. When the librarian asks, which book do you need, what would you say? You can say, I need the second book on this shelf. But the librarian wouldn't know whether you are referring to the second book from the left or the second book from the right. Therefore, you have to say, I need the second book from left on this shelf. Accessing the values in a list works in a similar manner. Here, we have a list with some numbers. If you want to access a number, you have to specify the location of the number in the list. The standard term for location in a list is index. Look at how the numbers are indexed in the diagram. If you want to access the value 96, you can say, I want to access the value at index 2 in this list. One important point to note is that the first index is not 1, but 0, and the indexes are considered from left to right. Therefore, the value 15 is at index 0, the value 20 is at index 1, and value 17 is at index 4. The standard way to access a value at a specific index is to call the name of the list, values in this example, followed by the specific index within square brackets as shown here. Therefore, if you want to access the first value, you call value 0, and if you want to access the second value, you call values 1. Let us look at a few examples. We will consider the same list again. The first step is to create the list. We can do so by writing values is equal to, within square brackets, 15, 20, 96, 32, 17. What do you think will be the output of this print statement? You can pause the video and try to guess the answer. Since the specified index here is 0, it will output the value 15, which is at index 0. Similarly, since the specified index here is 4, it will output the value 17, which is at index 4. You can see that this print statement is different from the previous ones. Instead of having a single index, it has a range of indices. You might think that it will output values from 15 to 32, as 15 is at index 0 and 32 is at index 3. However, it will only output values from 15 to 96. 15 is at index 0 and 96 is at index 2. Similarly, if the specified index range is from 2 to 5, it will output the values from 96 to 17, where 96 is at index 2 and 17 is at index 4. To generalize it, if the specified range of indices is from m to n, the values considered are from indices m to n minus 1. Now, let us look at how to update a list. There are several modifications we can do to a list. Again, we'll be using the same list here as well. The first operation is appending values to a list, which means adding values to the end of the list. Suppose we want to add 60 to the end of this list, as shown in the diagram using the purple colored square. As usual, the first step is to create the list. Next, to append the values, we can use the append method. When you call values.append 60, it will add 60 to the end of the values list. To check whether 60 has been added successfully, we can print the values list and check. When you call print values, it will output the entire content of the values list. You can see that 60 has been added successfully to the end of the list. The next operation is updating the value at a specific index. Let's say we want to update the value at index 2, which is 96 in this example, to 60 as shown in the diagram. The first step, as always, is to create the list. Now, to update the value at index 2, we use the statement values within square brackets 2 is equal to 60. What it implies is, update the value at index 2 of the values list to 60. To check the modification, let's print the list. We can see that the value now at index 2 is 60 and not 96. The third operation is removing a value from a list. Suppose we want to delete the value at index 1, which is 20. This diagram illustrates what we want to achieve. First, let's create the list. To remove a value from a list, one method we can use is remove. What it does is, it will remove the value given in the brackets from the list. Since the value at index 1 is 20, we call values.remove20. To check whether the value has been deleted successfully, let's print the list. We can see that 20 no longer exists in the list. If we take a step back and have a closer look at the remove function, we should know the value at a particular index to use the remove function. For example, here, we should know that the value at index 1 is 20 to use the remove function. However, there can be situations where we do not know or do not want to know the value at a particular index. In such situations, we can use another function called delete. When you call delete values within square brackets 1, it will delete the value at index 1 of the values list. So far, we have learned a lot about lists. One of the best ways to learn is to practice. Here is a practice exercise for you to try out. You have been given a code segment, and the question is, what will be the output if you execute it? You might find that the print statement here is different from what you have learned so far. We will learn about this later in this lesson. However, I encourage you to run this code and figure out by yourself how this print statement works. The answer to this question is available on the last slide. But please make sure you try your best before looking at the answer. The next topic we are going to cover is multidimensional lists. So far, we looked at one-dimensional lists where a set of values are stored between square brackets. An important question at this point is, how can we create two-dimensional lists? Before answering that question, we should ask ourselves, do we need two-dimensional lists? Let us take a matrix, which is something we all are familiar with. Earlier, in the library example, we said that we need the second book from the left. But in a matrix, suppose you want to access this 2 in the purple square. You have to specify not only its row-wise location, but also its column-wise location. This means now we are dealing with 2 dimensions. How can we store this data in a list? The easiest solution is to increase the dimension of the list to 2 as well. The variable data here holds the values of the matrix in a 2-dimensional list. You can see that there are 3 lists inside another list. Each internal list here holds the value of a row in the matrix. For example, the first internal list contains the values 1, 1, 1, which is the first row in the matrix. Now the question is, how to access the values in a 2-dimensional list? The answer is simple. It is the same way as accessing the values in a matrix. What is the coordinate of the 2 in purple square in this matrix? It is 1, 1 because it is in the second row and is in the second column. Therefore, if you want to access this 2, we call data 1, 1 because first, you have to find the internal list at index 1 and inside the list, you have to get the value at index 1 again. Similar to what we learned earlier, if you want to update this value, we call data 1, 1 is equal to 25. If you print the updated list, you can see that the value has been changed from 2 to 25. We can also do other operations such as append. What does this line of code do? We are instructing the program to find the internal list at index 1 and append 2 to it. If we print the list again, you can see that the value 2 has been added to the internal list at index 1. Now, let us look at some more list operations. The first one is to find the length or size of a list. The function we use here is len, which stands for length. The length of this list is 3, as the list contains 3 values. The next operation is concatenation. Suppose we have 2 lists A and B. If we want to combine the contents of the lists A and B, we can achieve it by using the plus operator. A plus B will output a single list with contents from lists A and B. You can see in the output that the values 1, 2, and 3 are from list A, and the values 4, 5, and 6 are from list B. The third operation we are going to look at is repetition. Looking at an example will make it easier to understand how repetition works. The list here contains the string high. If you multiply this list by 4, the content within the list will be multiplied 4 times, as shown in the output. Note that we are not getting 4 separate lists, but 1. The next operation is membership. The idea is to check whether a value is available in the list. In the given example, you can see that we are using the in operator to check membership. The statement 3 in list 1, 2, 3 checks whether the value 3 is available in the list. Since the value is available, it returns true. If the value is not available, it will return false. The final operation we are going to discuss is iteration. Iteration means going through the list one element at a time. The code says, for x in list 1, 2, 3, print x. How it works is, the first element in the list, which is 1 in this example, will be assigned to the variable x. Then the print statement will be executed. After that, the second value in the list, which is 2, will be assigned to the variable x. The print statement will be executed again. This pattern continues until the last element in the list. It might be a little confusing at this point, but do not worry, you will learn a lot about iteration in the next lesson. We have come to the last part of this lesson, which is indexing and slicing. Let us use an example to learn these concepts. Consider the given list, which contains 3 strings A, B, and C. We have already learned about indices at the beginning of this lesson. We need them to access the values in a list. When we call print L within square brackets 2, it will print the value at index 2, which is C. There is an alternative way of indexing called negative indices. In negative indexing, the last value of the list is indexed -1, similar to how the first value is indexed 0 in normal indexing. The rest of the elements are indexed from right to left. If you consider the given example, you can see that the last element C is indexed -1, then we move to the left, B is indexed -2, and A is indexed -3. Therefore, when you call print L within square brackets -2, it will output B. Slicing means extracting a part of the list. We have learned about this earlier as well, but without using the term slicing. If you remember, we said, if we use the range m to n within square brackets, it will consider the values from index m to index n-1. However, the print statement here is something which we did not learn earlier, but was used in practice exercise 1. When you say L within square brackets 1 colon, leaving the second part of the range empty, it means from index 1 up to the last value of the list. Hence, in this example, it outputs the values B and C. Here is an exercise for you to practice what you have learned. The question is, you have been given a list of numbers and you have to write a program to output all the even numbers in the list. There should not be any duplicates, which means if there are 2 4s, you have to output it only once. The answers to practice exercises 1 and 2 are available on the last slide of the presentation. We have reached the end of this lesson on lists. In the next lesson, you will learn about iterations in detail. Thank you.